My name is Nico Cherisani. I'm part of the benchmarks team here at LinearB, and today I'm going to be joined by Yishai Beery, CTO of LinearB, and Gal Rubin, our product leader, for a demo later on. Welcome to the Software Engineering Benchmarks Report release webinar. If you haven't gotten the report yet, we'll be in the chat and posting links into it. You should have gotten it in your inbox. If you haven't seen it, then maybe check the junk inbox. I don't know. And we're going to be walking through the report and insights today. Just a quick note, we have people in the chat. If you have questions about the report, the benchmarks, definitions, LinearB, what we do, all those types of things, plenty of people in the chat to talk to you about that. And our agenda today is going to be quickly walking through what's new in today's webinar versus last year, or in today's benchmarks report versus last year's benchmarks report, the 6 major insights that we found in the data this year, and also how you can operationalize your R&D investment profile within a LinearB platform and at your organization itself. So we're really excited to get started today. Please ask your questions in the chat if you have. So just a quick note about the report this year. We studied, this was a really big study, over 2,000 dev teams, almost 3.7 million pull requests were analyzed, over 100,000 active contributors for a full year time frame. You'll see in this report that we have these elite, strong, fair, and needs focus. This is, of course, how we talk about performance at any level. And this report, we added some new metrics that we're going to talk about here shortly. And since we kind of started expanding the list of metrics that we talk about, we categorize them into efficiency, your DORA metrics, and quality and predictability. So that's just a quick note on how to read it and what the study looked like from our end. Something new in the report this year is, of course, our benchmarking DORA. Last year, we had cycle time and deploy frequency. This year, we have all 4 DORA metrics. We're really excited to have them. And we benchmarked them by org size. This was a big addition to this year's report. Last year, we were doing basically just org by itself. And this year we're doing startup, scale up, and enterprise. As you can see, 0 to 200, 200 to 1,000, 1,000 plus employees is how we designate those categories. And we have benchmarking for DORA across all 3 categories. We are, as far as I have seen, I think we're the first ones in the world to ever benchmark against org size itself. So it's really exciting. Definitely go check out the org size charts in the actual benchmarks report. So we also added 2 completely new metrics to this report: merge frequency and capacity accuracy. Merge frequency, I'm going to let Yishai actually come in and talk about the definition of merge frequency and why it matters so much.
Thanks, Nico. So merge frequency, first of all, I'll define it. This is how often developers are able to merge their code into the code base. If a developer is able to merge 1 to 3 PRs a week, this is relatively high. We'll give them a high score in our benchmarks. If a developer is only able to merge 1 PR a week or maybe less, this means they are blocked. They could be waiting for other developers to review their code. They could be waiting for long builds. A lot of things that may be broken or not optimal in the process and are blocking developers. So this is a measure for developer experience. And we know that the happy developers are developers that are able to deliver. And that signal, can I merge frequently, is a great signal that there's not a lot of blocks, not a lot of weightage happening, and I can just get my code merged and move on.
That's awesome. You're going to see merge frequency all over this webinar today. You're going to see it all over the report. It's a major leading indicator of cycle time, right? There's a lot of, cycle time is this big DORA metric, and you can't just improve cycle time. You have to improve a lot of other leading indicators like PR size, but especially merge frequency. And this, we've measured this before, but it continues to come up as one of these most important metrics to look at. And anecdotally, I'll tell you that we know, or we hear often that, merging devs are happy devs. Everybody just wants to deliver, and merge frequency is a really good indicator of, are developers able to deliver? Are we being bottlenecked in our workflows? And help us point towards where we can apply maybe automation or new processes to create a streamlined workflow effect. We also this year included capacity accuracy. This is a predictability metric. Last year we had planning accuracy, and I'll let Yishai kind of talk about planning accuracy versus capacity accuracy and why you should be measuring it every quarter or every sprint.
Sure. So both planning and capacity accuracy are scores that help us understand how our teams deliver sprint over sprint. And the mapping between what we promised at the beginning of the sprint, what we plan to do, and then what actually happens, and what gets delivered when the sprint is over. And if planning accuracy focused on, are we delivering the actual stories, the actual content that we promised? So if I'm delivering everything I promised, that the best I can get is 100% with planning accuracy. Capacity looks at this from a different angle. We're not looking at which items we delivered, but rather what is the capacity of the team? And are we promising an amount of work? This could be number of issues, or it could be story points. Is the amount that I'm promising actually making it? And are we delivering the same amount at the end of the sprint? The context may differ. This could be, there could be scope creep, new urgent things coming in, bug fixes, whatnot. But as long as we're delivering the same amount or similar, so we're roughly within some bracket around 100%, this means that we know the capacity of the team, and the team has a mature practice that they're able to know this is what we can deliver. Even if the contents are shifting, we can still deliver that amount. If the team is not mature enough in their process and they're not even sure what capacity they have, then this will fluctuate, right? Some sprints will be way above what we promised, some sprints will be way below. And as the team learns to pace itself, now it has the right visibility into this is what we can deliver, this is the amount. Now let's fill it up with stories. Again, planning accuracy will keep us honest to the actual scope, and capacity accuracy will help us maintain that predictability in terms of how much work we can deliver.
So these predictability metrics are all about being able to deliver on our promises to the business, right? There's business stakeholders on all teams kind of waiting on a development to ship the feature, right? And it's really can be challenging to forecast, especially that delivery date with so much work to do. So we use these metrics to look at them and stabilize them over time. Just like Yishai said, you can also take things, metrics like cycle time into consideration here. You want to have a very stable cycle time so that you understand how much work you can take on and deliver over a certain period of time. You can break down your projects into sprints and know what you're going to be able to produce. This has been, it's really important to be able to, deliver on time and forecast better than maybe what we can do anecdotally. And I think even Yishai says that it's more important to have a on-time delivery than a super highly efficient delivery.
Yeah, predictability in many cases trumps raw performance or raw productivity. And capacity accuracy, planning accuracy are great ways to understand our predictability at the sprint levels. And then cycle time helps us understand, or if cycle time is kept short, we can have more predictable delivery of PRs, stories, and eventually sprints.
Well, the final addition to the report this year that we'll focus on is the R&D investment benchmarks. So we added these in this year. We're very excited to have them. And we will actually be looking at a product demo later on today about how to use these inside of the LinearB platform and within your own organization, how to operationalize them. I'll leave it to Yishai to kind of break down the different categories that we have and how we decided to calculate these numbers as a starting point for your org.
Sure. So we're basically looking at the scope of all the work done. This is taken mainly from your ticketing system, such as Jira. And categorizing every piece of work, every issue into these 4 buckets. So new value would be the investment in a new feature, a new product, new capabilities that open up to more customers, more markets, more revenue. This is the core part of the company's growth, at least where it comes to how your product and your technology powers that. Feature enhancements are the incremental improvements to existing products. So this could be adding some more capabilities, fixing non-urgent bugs, improving performance, fixing or tidying up flows. Basically, additional work done on existing products that you already sell, that you already have available. Developer experience is all those investments that are internal to the engineering team. Basically, everything we do to help tomorrow's engineer to be more productive. So this could be more tests or a test harness. This could be investments in your pipelines, in your CI, quality, tech debt, everything that you're doing now to improve your experience as a developer tomorrow on your code base. And then KTLO, keep the lights on, is that unavoidable tax that you have to pay to keep your systems up and running. This is all of those maintenance tasks, cleaning up databases, deploying larger machines as you scale, dealing with critical vulnerabilities or security scans, everything that is a must to keep your product running, even if you're not adding any new feature, and just maintaining what you have. This is going to keep the lights on.
Awesome. And Yishai, tell me about these numbers. How did we get to the 55, 25, 20% and other?
So we took this categorization, again, based on a rule set that, as you can see later today, you can then modify in the product. And we're applying this to the data that we're seeing from our wide range of customers, and basically seeing this is the behavior that we're seeing out there. So typically we see north of 50% investment in new value, around 10% around in KTLO. And obviously every organization, every dev team will have a different mix and also different targets. So this represents the common case or the average, if you like. But then a team that is working on a brand new product might want to have a much higher value for the new value category, whereas a team that is maintaining an existing stable and mature product will probably have a lot more in feature enhancements. And then a team that is now investing in improving their work, their code, so that they can reduce KTLO, are probably looking to have a higher investment in developer experience items. So these are what we see out there in the wild, and then every organization can change their own benchmarks and say, I want my numbers to be like this.
That's right. That's just such an important point here. These numbers are a starting point for engineering leaders to understand what type of investment they're making, and then set some goals and align with the C-suite to say, this is where we're putting our time and effort. This is what our improvement strategy is going to be. And this is a good place to kick yourself off and say, okay, like maybe this is our average, or maybe we need to put 70% into new value as we need to increase our logo count or something. So it's a really great thing. We're going to have Gal Rubin on in a little bit to talk about how to set these inside of a product and track them over time so that you can create a strategy to improve your organization. So with that, we're going to move into the next portion of the webinar today of the 6 data insights of the 2023 Software Engineering Benchmarks Report. And I'm going to switch roles with Yishai and let him take over the hosting role. So we're going to go and start with insight number 1 of pickup time, handoffs versus review time.
Thanks, Nico. So we started by looking at the behavior around the review process and pull requests, and looked at 2 high correlating numbers that stood up. One is the pickup time, and I'll repeat the definitions. Pickup is how long are we waiting once the PR is up until someone begins to review it. This is basically pure wait. The PR there's no progress happening. We're just waiting for someone to start. And then review time is from that point where someone started all the way until the PR is merged. The whole review process, back and forth, changes to the PR if needed, and eventually merge. And the correlation on the top tells us that if the PR waits longer to get even like the review started, the review itself is going to be longer. This could be because the PR is larger, more complex, and developers tend to push away and not even start the review if it's going to be a huge review. But also because when you defer the beginning of the review, when you actually have some comments and you're looking, you're making some comments back at the developer, they've already moved on, right? If you waited 2 days to start the review, I'm already in my next PR or even two PRs ahead. I'm doing something else, and now it's a much more expensive context switch to get me back to responding to those comments, making changes to the code, asking for a second review, and so on. So the longer we have the initial wait, the more expensive those context switches are, and we also have a little less urgency now, right? It's already waited. There's so maybe we can let it dangle on for longer. So this is the first insight here, where if you said the delay begets delay, if you like, pickup will highly correlate with a longer review time. The second one is looking into how many handoffs does a PR get before it gets merged. And whenever the person on the PR changes, right? I'm writing my code, issuing a PR. I'm the first hand. Now someone else is reviewing my PR. They're the second hand. And if now they send me some comments and I have to look at them and respond back to another hand. So every switch like that is what we count as a handoff. And it's not surprising that the more handoffs, the longer the process, right? Every handoff is an opportunity. Almost by definition, it's a context switch for someone because they weren't working on the PR and now they have to get back to it. So handoffs are very expensive, if you like, in terms of review time. They force a context switch on someone, and sometimes people are not available at the right moment. They're maybe in different time zones. Like I said, they're busy. So there's a lot of wait happening whenever there's a handoff. So this is a strong contributor to and predictor for review time. And this tells us that teams need to think about how do we reduce handoffs. And I'm going to talk about some strategies for doing this. I would say the first and foremost is provide more context as you create the PR, right? In the PR title, and it's the description, the code itself with comments. Where should I focus as a reviewer? Whatever you can do to help the reviewer is probably going to get you less handoffs and less chatter around the PR. But same goes for the issuer, right? If you have a comment, make a comment that is easy to understand and parse and action on, and not just say no on a piece of code, right? You're bound to get a ping pong if your comments are very terse or very hard to read. So providing more context, helping each other, helping the next hand do their work. That's number one. Number two, at some point, if there's so many handoffs, think about going sync, right? Jump on a huddle, get a room. So like after so much like chatter, the async model for pull requests starts to break down, and you can spiral into endless debates or a very long delay. And if you can find a few minutes together, you can finish this review, iron out the last outstanding issues, and get the code merged. So there's a point, and I'm encouraging teams to identify that point where here is where we can maybe move from async to sync and stop the handoffs. And finally, think about automation, right? Whenever you can automate some parts of the PR review, for example, automatically reject PRs that do something that you know is wrong, or frowned upon in this code base. Why have a developer in another like handoff just to review this and say, don't do this? So automate things like that. Maybe we can automate some of the PRs and not even review them at all. Are there some PRs in your code base that with enough checks you can automatically approve or let the developer just merge them? All of these are great opportunities to reduce handoffs and obviously cut down review time for specific PRs and on average.
That's right. And this is reducing the pickup time and the review time. These are the two middle components of cycle time. At LinearB, we break down cycle time into coding time, PR pickup time, PR review time, and then deploy time. And so adding this context, adding some automation around these is going to allow you to ultimately ship faster and decrease your cycle time and your overall DORA metric there. So
Right.
it's very key. You don't just decrease cycle time. You have to decrease, and you have to work towards decreasing pickup time and review time.
Right. These are the two segments that are very heavy in, human interaction, communication, which can break down, can be inefficient. Like I said, context, coding, and the deploy are the parts that are less dependent on humans interacting, and less async in its nature, which is why pickup and review are great areas to focus on.
That's right. Great. Well, let's move on to number 2. Here's that merge frequency metric again, and versus the PR review cycle. So that's going to be the pickup time and review time that we just talked about.
Right. So just to remind us, merge frequency is how often do developers merge their code, and this is a great signal of are they blocked or unblocked in their work. So the first correlation, and basically both of these show us a correlation between merge frequency and pickup and review time. The higher the pickup time or the review time, the lower your merge frequency is going to be, and vice versa. On the surface, it's not surprising, right? I have more wait, I'm waiting for pickup, I'm waiting for review to happen, or to finish. That will block me from merging my PRs. But what this also tells us is that you could argue that, okay, just having some things wait longer. I have a long list of PRs that each live for 2 or 3 weeks, and eventually we'll get there, but I'm doing many things in parallel. I'm not idling. I'm doing the other PRs. And if I have enough of those, I'm going to be able to merge frequently just after a long time. And this data tells us that this is not true, that, running a lot of PRs in parallel has a very concrete tax. You're paying with context switches and with your attention and with we all know high WIP is bad for you. So this correlation tells us there's a direct cost to having long waits, and it's not just about things will happen later, they will also happen slower.
That's so interesting. You talk about this context switching a lot. I think we've created data on this before. It's something like 20 minutes of costed time per PR for every context switch?
So there's a lot of research out there about the cost of context switches. I think typically pegging a context switch around 20 to 25 minutes. Every context switch requires like that time to get reoriented and get back into work or into the new piece of work. And our research actually showed there's a lot of like the idle time happening in PRs. So in many cases, and you've seen this with handoffs, PRs require multiple context switches. They have multiple handoffs. So in many cases, much more than those 20 minutes per PR. This could be 20 minutes times 4 or 5 per PR. And that's if you're just, paying just those 20 minutes. Sometimes the cost is higher to context switch. But every developer you ask, like, what is the number thing that they hate, is not having uninterrupted time to work. It could be meetings, it could be Slack, it could be alerts, anything that is interrupting them, because developers know that context switch is toxic to their ability to work and write great code.
That's right. I think the key takeaway here is about dev efficiency, right? That's something I think we all can agree that we want to work on and improve and improve over time. And what this data is ultimately saying is keep your WIP down, keep your PRs small, and keep them moving quickly, and be attentive to them so that your pickup time is quick, and then the review time is going to be very quick thereafter. You're increasing your merge frequency and decreasing your overall cycle time. So you're delivering.
Right. This goes to the efficiency of the team and the developers in it, but also to their experience. And like I said, developers that are blocked, they're not just inefficient, they're also unhappy.
That's it's such an important point. You know, when you merge code, you get a little dopamine hit, and that feels really good. And you want to have that happen. So keeping your PRs small and merging several times a day is a really ideal state for everybody, including the business and the devs.
Yep.
Cool. So let's go into, we talked a lot about cycle time. But let's talk about cycle time by org size and insights 3 and 4 today.
Right. So this is where we started looking at the different behaviors across or split into the 3 bands of org sizes: small startups up to 200 employees, scale ups up to 1,000 employees, and then beyond that, we categorize those as enterprise. So the first thing you see, cycle time is longer for the enterprise. You can see enterprises on the far right of the graph, pretty well separated from the startups and scale-ups. Perhaps not surprising. You need to go or jump through some more hoops in the enterprise to get your code all the way to what we call deployed, which it's flexible, but this is a kind of end state for your code, production or similar. You can also see that this correlates with lower merge frequency, right? It takes you longer to deliver your code. Eventually, having those PRs in the air, even after merge, even just waiting for deploy, is a tax on the developers and their ability to merge more frequently. And you see this correlation here, both between the cycle time and the merge frequency, right? Lower cycle time, higher merge frequency, and you see the difference in behavior between enterprise and then startup and scale up. This tells us that enterprises and dev teams within enterprises should perhaps make an extra effort to look for those opportunities for automating, for orchestrating the communication between people around the PRs and getting their code merged and deployed. The investment there is even more needed because of those gaps.
Yeah. Wow. I guess I can't be entirely surprised that the enterprise is moving a little bit slower. There are more processes and security involved, but the correlation with merge frequency is just so obvious to us, and it's why we keep on focusing on this this key indicator of to cycle time and to our DORA metrics. Right? Again, you have to build a kind of practice around improving your pickup time, improving your review time, and your merge frequency in order to decrease your DORA metric of cycle time. And this data just goes to show that.
Yep.
Great. So rework versus cross-team PRs, insight number 5.
Right. So let me start by defining rework rate is that portion of the new code, the code is getting merged to the code base, which is replacing code that only just made it to the code base. So if we're looking at everything we add to our code base, some is net new code lines, completely new. Some are modifications of existing code that, we had some code laying around, some refactoring, we called it that refactor. And then if the code that we are replacing has only just made it, it's only been in the code base for, I don't know, a couple, 3 weeks, this is a code that we are reworking, right? It hasn't really had a chance to deliver anything or live in the wild, and we're already changing it. At some degree, this is always going to happen, but if the percentage goes up, the higher the percentage, this is an indication of some waste, right? I'm working on code that is only living for a couple of weeks, and then I'm replacing it. That there's some waste hidden there, and also an indicator of possible quality issues, right? Why am I changing this so soon? Probably because it wasn't good enough. Did not work in all cases, did not fit other components around it, and so on. So we see on the enterprise, somewhat elevated rework rate, I would say on the tune of about 16 or 17% higher than what we see in startups. And that hints that there may be like a overarching quality difference, or difference in the dynamic in how code is being developed in enterprise. And to help us understand that, we are also looking at the cross-team PRs. So we define cross-team PRs as PRs where there are contributions from people that are not all in the same team. So I may be issuing a PR. I wrote the code. Someone from a different team is reviewing it. That is a cross-team PR. Or if we have commits from people on two different teams, again, that is cross-team PR. Whenever we are requiring people from it that do not all live in the same team inside this one PR, we call that cross-team. And you can see that startups have a much higher percentage of PRs that cross the team boundary compared to enterprises. Enterprises have a much more siloed approach here. They get their much more of their PRs started and all the like reviewed and eventually merged by people within one team. Whereas startups the boundaries are much less dominant, and you have much more collaboration between teams here. This may be because startups just have to; they don't have enough people to be able to neatly put everything into siloed teams. Also, because enterprises sometimes have longer history, and there's older products they have to maintain and so on. So there's maybe tends to create teams that are a little more isolated. But we think this could also be hinting that when you have that cross-team behavior, when you have people from other teams exposed to the codes being changed and making their comments and reviews, you're able to find possible integration problems sooner, right? If a team is working on something, it looks great for the team, and the integration problems only rewrap after the thing is merged and then hits additional tests and runs into problems where that component integrates with other teams' work, that will cause rework, right? This will get fixed probably way before the code is deployed, but probably after the PR was reviewed. If you have people from other teams involved in the PR review process, you have a chance to find those problems and prevent them earlier on. So this could be what's happening here. And what we see, like the difference between enterprises compared to startups across these two metrics.
Wow. This is one of my favorite insights of the report this year, by far. It's just so interesting. And this data is a long time coming. About a year ago, we had a VP of engineering come to us and say, "Hey, I want to measure my cross-team PR percentage." That gentleman was looking for a measurement to understand are teams working together and are they sharing knowledge across teams, so that like it wasn't just like 5 people know all of the village knowledge, and then if they leave, they take it with them, kind of a situation. And what we found now with this data is that it's not just broad learning, which is of course a massive benefit, but also it's improving your overall code quality, and that is just so important. So of course there's always a balance. But advocating and putting some processes in place, even some automation in place to take some level or percentage of your PRs or some type of PRs and make sure that they are crossing the teams, can improve your quality at a very tactical level, but I'm sure also improve your developer experience and empathy across individuals and teams.
Yep.
Cool. So our final insight today, going back to merge frequency versus working day. Tell us about this, Yishai.
Right. So we try to understand a little more what is interacting with merge frequency. Again, the developer experience, our ability to merge code frequently into the code base. So we took a look at the dynamics of the workday. Looking at every developer's, all their basically activity with the code base, commits, reviews, merges, and so on, and mapping that onto the day and finding the typical length of the workday. And this differs between people, right? We have developers that spend all of their time within roughly 10 hours a day, and others that spread this across 14 hours a day. This could be affected by work from home versus office and others, but we see a pretty strong separation where startups have a longer workday on average compared to the scale-ups and enterprises. Not a huge difference. It's about a half an hour, but this adds up, and it's a half an hour on a 8-hour day is not too small. And you can see, again, this correlates with a higher merge frequency. So, you could say more working hours, I can get more things done. But we think there's something a little more complex going on here. So we took a look at the overlap. We're looking at a team and are saying how much of the workday is actually, we get good overlap between the people in the team. Like everyone is active, or above half of the team is active. That was our threshold. At least 50% of the team, this part of the day is within their workday. And what we see is that startups have not just longer working days on average, but a much higher overlap in their teams. So a team has much more time together. And this, again, strongly correlates with the merge frequency. So this tells us it's not just about the length of the day, but also being around for each other to do quick reviews, right? If I'm also working while you are, and you just put up a PR, I have a chance to review it quickly. If I'm in a different time zone, if I'm already signed off for the day because my day started much earlier than yours and ended half an hour ago, you're going to have to wait until tomorrow for me to review that code. So having longer overlap every day between the team members is also key to getting your merge frequency up and to providing a little more synchronous behavior between the team members as they work together on their code base. So enterprises have like much less overlap. This could be about wider geo spread, time zones, maybe the ways that teams are organized. And my takeaway is to like proactively think about that overlap when you're building a team, when you're trying to shape how the team is working. Be aware also as the team members having more overlap, being there for each other, and not like living on islands and just doing my thing has a tremendous impact on the ability to get things done in a team.
So interesting. I'll share an additional insight that maybe it didn't make it into the report, but we found it kind of interesting. It wasn't quite statistically significant enough to make it in. But when we were looking at average working day, we saw, geographic locations are a little bit different, not really enough to like talk about too much. But what we did see was a little bit interesting. Yishai, can you talk to us a little bit about, what we saw in Europe?
Yeah. So again, not significantly enough to make it to the reports, but we did see that in Europe, on one hand, the average working day is shorter. So companies in Europe are able, and dev teams for those companies are able to keep a good balance between their work and life. But this does not come with a distinct penalty on your on merge frequency and other key metrics. This could be because the overlap is still high, right? The day is a bit shorter, but the overlap, everyone is working at the same time. And in general, it probably tells us that just working longer doesn't automatically help with more productivity. And yeah, kudos to the Europeans that are able to keep their days short and productive.
That's right. It was about the same merge frequency that we saw across the board for everybody else, but the European teams were working less hours. So I guess the work smarter, not harder, is the key takeaway here. Yep. Awesome. Yishai, thank you so much for joining us today. This was great. I'm going to kick you out and bring in Gal Rubin into the webinar. We're going to be talking about benchmarks in the boardroom next. So, when we talked about that investment carving, right? Keeping the lights on and feature enhancements and new value. We wanted to show you how we capture that inside of the LinearB platform and how engineering leaders can use that to create reports and understand where their teams are putting in the work. So I'm going to stop sharing and let Gal give you a live demo. Hey, Gal, how you doing?
Hey, Nico, thank you so much. And thank you everyone for joining us today. I do want to share a quick demo of our recent new closed feature, which is the investment profile. But before diving into this feature, I just want to talk a little bit about what it is and why is it important. So different companies may have different preferences when it comes to allocating their resources across the different investment profile. Some companies may prefer to invest more in new value activities, such as developing new feature, developing new platform, while other companies might prefer to invest more in feature enhancement activities to ensure customer satisfaction, improve their existing products. But regardless of the differences between the different preferences for each company, there is no argument that this type of information is still super important to track and follow. And one of the main reasons is because it helps us to create a healthy discussion around some of the burning questions, questions that usually come up in board meetings, questions like, what is the golden ratio between investing in new value versus feature enhancement? Or is it possible that we, an organization, have a quality issue that manifests in high KTLO? So that's one of the main reasons why we built this feature. We wanted to give our customers the ability and the visibility to this data to help them answer these questions. So let's dive into this. So we see here the investment profile feature. You will see it as a new tab under the projects tab. And if I look here, I will see that my resources span across 5 projects. I have 31 FTEs, full-time equivalent, working on these 5 projects with an estimated cost of a little bit over $1.5 million. Now, if I look here at my investment profile, I can actually see how our organization is comparing with LinearB benchmarks. So for example, I see that for the new value, we're investing almost 30% when our goal for the benchmark is 35%. Which is good. It means we're in the right direction. If I look, for example, at the keeping the lights on, the KTLO, I will see that we're investing 7.5% when the benchmark is 10. So that's also good. It means we have some breathing room. And when looking at these categories, we see that most, if not all of them, are very familiar in the industry, feature enhancement, KTLO. But I do want to focus on one category that is more unique to LinearB, the inefficiency pool. The inefficiency pool is a new category that actually helps me to identify and measure the percentage of inefficiency across my development process. What it does is it looks at impact metrics such as PR size, PR review time, and takes into account parameters like the number of active people, the number of FTEs, and the number of working hours. And it can actually quantify a certain percentage of inefficiency. Usually that inefficiency comes from things like idle time and context switch that can affect heavily on your metrics. But we can actually identify it and also recommend ways on how to improve and decrease the percentage of inefficiency, either by using histogram automation, setting team goals, or tracking other impact metrics. So one of the questions that I've been getting when I'm presenting this feature is, how do we calculate this data? How do we even decide which work falls under which category? And the answer is pretty simple. So if I look at each category here, I can see exactly what is the mapping for it. Let's look at new value, for example. I can see that all the work, all the issues of time, either epic, story, feature, theme, or initiative, will fall under the category of new value. And of course, I can completely configure it. If I click on this edit category button here, I will be delivered into the configuration screen. And I sort of have like even a rules system engine here. I can play around with the rules that I already have, or I can create an entirely new rule. So let's say that I'm an organization and I don't work with theme and initiative. So I can just remove this from here. Or I can create an entirely different rule based on parameters like issue type, label, field, and even keywords. Additionally to this configuration, I can also configure the percentage of benchmark. So let's say that we're an organization in the beginning of our way, and our main focus is currently to develop new features and develop new functionalities. So I don't want to invest 14.5% in new value. I want to invest 60%. So I can just play around with these benchmarks here. And once I hit on save and close, when I check again the investment profile, I will see how I compare according to the new benchmark I've just defined. So again, investment profile is more of a high-level organizational view. If we want to look at how resources are allocated in a more granular level, we can always do that by going into resource allocation and see exactly how resources are allocated by other projects, initiative epics, and even custom fields and labels. For example, if I look here in the allocation over time chart, I can see that LinearB has been investing heavily in this project for the last 4 months. I can see what is the percentage of FTE that this project has been spent on. I see that I have 73% of the total FTEs go into this project, with an estimated cost of almost $170,000. If I look here, for example, I can also view this information by custom field. So we have a custom field where we tag the area or domain in the product that we're working on. So we can see that the main areas in the product that we invest in is the metrics and the PDT, which is not surprising. It's 2 key areas in the product. It really aligns with reality. And I can also do another cool thing, which is view my allocation by labels. So in LinearB, we tag our work with label according to team. So for each team, we have its own label. And we can actually see the distribution of work between the different teams. We can see exactly who is working on this team, who are the top people that have been contributing the most FTEs, how many FTEs in average, what is the estimated cost for this team, how many issues that have been working on, and the investment per issue type, whether this team is working on mainly on stories, bugs, releases, so on and so forth. So this was a very high-level overview on this demo. So thank you again for letting me introduce this, and going back to you, Nico.
Awesome. Thank you so much, Gal. That was amazing. We are so excited to have that new feature out. And with that, that is going to just about finish us up today. Hey, let's start a metrics program together, friends. If you aren't already a LinearB user, you can, of course, start a free account with us and start getting your metrics within hours, your cycle time and deploy frequency. You can, of course, book a demo to take a deeper dive into resource allocation and project delivery tracker and how we forecast against deliverables. If you're just kicking off your engineering metrics journey, I highly recommend the Engineering Leader's Guide to Building a Metrics Program. This takes you from 0 to 10, no problem, and you'll begin to understand how to implement these benchmarks that we've talked about today in this data to start improving today. And our final pitch is on October 10th. LinearB and Dora team from Google are partnering on the 2023 Accelerate report. We'll be sending that out to our friends like you in mid-October, but we definitely are inviting you to join us. There's a link in the chat now, or there should be, to register for that event and join us as we walk through the insights from the Google Dora team. So that's going to be a very exciting upcoming show for you. And with that, that will end our journey today together. I hope you enjoyed the benchmarks report. We sure enjoyed making it. Please share it with your friends, and we will see you all around. Thanks so much.